Hi, everybody. My name is Erin Beck. I am from SpaceX. Thank you very much for sticking around until the end of the day. It's been a long day, but I wanted to thank NASA ISS Research Academy for bringing us all here. To have the principal investigators, payload providers, developers, integrators, sponsors, and launchers all in one place is quite an exceptional treat. So thank you for having me here to give you a little talk about what it is that we're offering at SpaceX for you to get your science up into space. And here we go. A lot of you will recognize some of this picture. We had our first flight of the Falcon 9 on June 4th, just a couple months ago. And with this great success behind us, we've got another flight coming up in a couple of months, and that's going to give us a good footing to provide you a lot of opportunities to get to space in the next couple of years. Next slide, please. So for those of you who don't know SpaceX too well, we were formed in 2002. We have just hit about 1,200 employees. To give you an idea of how fast we're growing, I'm just coming up on my first year at SpaceX. When I was hired in, I was number 800. We are now up at 1,200. So I haven't been there very long, but I've already been there longer than a pretty good chunk of the company. So in order to meet the production that we have coming up our way, we're bringing in as many talented people as we can. Our main base is in Hawthorne, California. Go ahead to the next slide. In Hawthorne, California is our main warehouse. We do just about all of our production there. We do almost all of it in-house. The reason that we bring all of our production in-house is to offer the best prices to our customers. If we can control the quality, the timeline, and the price of all of the components of our spacecraft and vehicles, then we have best control over the prices that we offer to our customers. We've found that that streamlines us and keeps us lean enough to offer the launches that we do. The two launch sites that we have are in Kwajalein Atoll and Cape Canaveral, Florida. The Falcon 9 and the Dragon capsule, which will be the focus of the talk today, do go out of Cape Canaveral, Florida. The vehicle is now completely in Florida as of today, and we're beginning the final integration processes. And we will be starting a launch site in Vandenberg probably in the next couple of years to increase the throughput on the Falcon 9. A lot of our testing happens in McGregor, Texas, which is just outside of Waco, not too terribly far from here compared to the Cape in California. We do our structural and propulsion testing there. Next slide, please. This is our line of rockets that we have built, have flown, and are working on. You see the Falcon 1 and the 1E at the bottom are the two that we launch out of Kwajalein. Those are for our small satellite class kind of payloads. The Falcon 9 is the one that just took off and is the one that will take Dragon. Falcon 9 can launch about 10,000 kilograms to LEO. So if you keep that base number and the idea of the number of engines on each flight, you can kind of back out from there the payload capacity of the rest of the rockets. So the Falcon 1E does do about a factor of 10 less than the Falcon 9. It can launch about 1,000 kilograms up into orbit into LEO. And then we have about 3 times that on the Falcon 9 Heavy, which is basically 3 Falcon 9s all put into one, which gives you about 30,000 kilogram capacity up to LEO. And again, we're going to be focusing on the Falcon 9 with the Dragon capsule. That's the one that'll be taking your payloads up. Next slide, please. So the Dragon spacecraft is basically a spacecraft bus. Right now it's being designed through the NASA, COTS, and CRS programs to transport cargo and eventually crew up to the International Space Station. We will have 3 NASA COTS flights. Those are all due up in the next basically in the next year. C1 will be the one coming up at the end of September. C2 and C3 are spec'd for early next year. And then we'll have 12 CRS flights after that. So basically the demo flights are to demonstrate that we can carry cargo up to the International Space Station and dock. And the CRS flights are the actual missions that carry cargo as a service for NASA. If you go ahead to the next slide, go ahead and skip this one, go to the next one. We give you a full, complete idea on what this mission is going to look like. So here's what we conceptualize as a Falcon 9 launching off from the Cape, pretty similar to what we saw a couple of months ago. So at the end of the first stage burn, we have separation, second stage burn. When the second stage burn is complete, Dragon with its trunk will take off, or will separate from the second stage and make its way towards the International Space Station orbit. As we home in towards the International Space Station, we make a target for the robotic arm, which will reach out and pick us up at a grapple location and bring us into dock. So for the first C1 demo flight, we will not go to the International Space Station. We will simply be demonstrating the Dragon capsule. For C2, we will approach but not dock to the International Space Station. And then for C3 will be the first time that we actually make contact with the station and dock. And there is planned to carry at least some cargo on that mission as a demonstration. So once Dragon has docked, we can open up the airlock and the astronauts can come into the capsule, unload the cargo, bring it onto the International Space Station. For science payloads in particular, that means bringing the science payloads out of the capsule and loading them onto something like an express rack or wherever their final destination is within the International Space Station. Once that mission is complete, the grapple bar takes us back out away from the station, and we start our depart into a re-entry position. As part of our departure, we do jettison the trunk, so now you just see the Dragon capsule coming back in. Launch our 3 drogue and 1 main parachute, come into a safe water landing just off the coast of California. We get picked up by either a helicopter or a boat, bringing all of the return cargo within the Dragon capsule safely back to land. Next slide, please. So we just talked about the COTS program as the one that should conclude within the next year or so. That's our demonstration flight. That feeds into 2 things. One is the NASA CRS program, where we provide the service to NASA to bring payloads up to station. And then the other is the Dragon Lab program, in which we take our capsule and we basically use it as a free-flying bus. So we utilize the kinds of racks that we're already using for the CRS flights, the racks, basically shelving units that are holding the payloads and cargo. And use that for commercial use. So rather than going up to station, we'll take it up and fly it around the Earth for about 2 years and then bring it back down. Those missions can go 2 weeks to 2 years. 2 years is kind of our maximum. Go ahead to the next slide. Okay, so here is the Dragon spacecraft. We'd already kind of talked about the capsule and the trunk. I'll tell you a little bit more about those. The capsule is where we carry all of our pressurized cargo. The pressurized cargo will not be pressurized on the way down, but is pressurized on the way up. That is where all down cargo will come. So pressurized up cargo, and then all down cargo mass comes down in the payload capsule. Down below that is the payload trunk, where we take all unpressurized up cargo. So things like that could be sensors that require immediate access to the space environment, or a large aperture viewing area at the bottom of the trunk. It can also include small satellites and payloads, so things like CubeSats, ORUs that would attach to FRAMs on the underside of the Dragon capsule in the trunk. All things that would go in there. Anything left in the trunk on the way back down does burn up as it re-enters the atmosphere. And then the nose cone on top is there just for the aerodynamic purposes and thermal protection on the way up. It is jettisoned on our way to the International Space Station. And there's this little bitty tiny section. Ooh, sorry about that. Little bitty tiny section right. Oh. Little bitty tiny section right here, which we call the service section. Service section is basically where we carry all of the avionics, propulsion tanks, and thrusters that support the Dragon capsule. There is going to be a tiny, small, itty-bitty amount of payload space in there. So for people who are interested in sending up unpressurized payloads, but getting them back as down mass, down cargo, there is a small, about 0.1 cubic meter area in there that we can fly payloads of that kind. Go ahead into the next slide. Okay, so here are some development pictures of the spacecraft, just to show you that this is in work and this is being built and this is actually going. Anything that you see inside was taken at our Hawthorne facility. We do build it up again right there in sight on the floor. And if you come and take a tour of SpaceX, we can walk you right up within a couple feet of it if you'd like to take a look. And then anything taken outside is at the McGregor test facility where we were doing our structural testing. Next slide, please. And this is the fully integrated Dragon qualification unit. So this is Falcon 9 Flight 1 sitting in the hangar at Cape Canaveral after we were fully integrated. This Dragon capsule did not include a full suite of really anything. It was just a demo, just a qualification unit with some instrumentation so we can look at thermal and load properties of the craft. But this is it getting ready to go out to the hangar, or out to the launch pad. Next slide, please. Little idea of the hangar. So for payloads that are going to fly on the Dragon capsule, those payloads are delivered to our Cape Canaveral site at SLC 40. They're delivered to the south side of the integration hangar where we have a dedicated space for payloads. Payload is brought into the site at about L-30 days, and it starts getting integrated at about L-14 days. Late load cargo can go in as late as T-9 hours. So you can see the Dragon Lab or Dragon CRS processing area down here at the bottom. We will have clean tents available for any satellites or payloads that need that kind of capability. For you guys as the payload developers for the CRS and COTS missions, that's all going to be taken care of as NASA, from NASA. You hand over your payload to NASA and they take care of getting it over to us and getting it ready for integration onto the vehicle. So that's not something that you need to worry too much about. Everything is horizontally integrated with the exception of when we immediately stuff the Dragon capsule, and I will get into that a little bit later. Next slide, please. This is the Cape Canaveral SLC-40 site. You see the hangar down here at the south end, the transporter erector, which holds the rocket erect in the center on the launch pad, and then some of our pneumatics and fuel and oxygen storage facilities around the outside. This is also a place that we love people have to come visit, so again, please let us know if you're interested in a tour, and we'll be happy to show you where it is that you'll be flying your experiments. Next slide. So to get a little bit more into the COTS or the CRS program, next slide, tell you exactly what the payload accommodations look like. So we needed to accommodate a wide range of NASA standard payloads. So we do half, single, double, and triple cargo transfer bags, soft bags with a mid-deck locker size. We do MO1, MO2, and MO3 bags holding multiple CTB equivalents each. And then we also have space for single, to either two single or one double hard-mounted powered mid-deck locker equivalent. So that could be a glacier freezer, as you're seeing outside, or a payload of that kind. For the CRS missions, that is the only thing that we currently have available that is powered. Everything else is passive. It goes into the soft CTV bags for up and down. For the Dragon Lab flights, we will add in the capability to have powered payloads all over the spacecraft and accommodate a lot of them. But for CRS, we are just dealing with these right here. Like I said, at T-9 hours is when we can do late load, and we're looking at return plus 6 hours for early access. Early access in this case does mean early access out in the ocean on a boat when we get to the capsule for the first time, and then it's another 24 hours to actually get back to shore. But with the proper research equipment in place on the vessel out at sea, you can certainly begin your research out there on site. And that, again, is something that you would negotiate with your NASA integrators. And then SpaceX would simply provide per the contract with NASA. Go ahead to the next slide. So this is what the cargo racks look like for a CRS mission. The MLE hard mounts that I talked about are pointed out right here in the middle. They're attached to the side hatch, which is why they can be the very last thing integrated onto the spacecraft. Everything else is passive, and it's basically like a walk-in closet. If you were to remove the late load side and the MLE hard mount and the central stack, you can walk right up into an area surrounded by 3 racks, which are basically just shelving units. We bring in the payloads, slide them into the units, strap them up with buckles, and then load the late load and the central stack last. Go ahead to the next slide. Okay, so this is what the late load and early access would look like. This is kind of an interior view of what the shelving units look like. The late load areas are accessed through the side hatch. So once the Dragon capsule is attached to the launch vehicle, it's in a horizontal position, we can open up the side hatch, bring the payloads up, insert, close the side hatch, and get ready for launch. Next slide, please. This is, like I said, the single, either 2 single or 1 double powered mid-deck locker equivalent hard-mounted slot. Next slide. And this is an example of the cargo loading. So about once a month, once every 2 months or so, we do demonstrations of the cargo loading. Oftentimes it's with the astronauts who will be handling that cargo, coming out and telling us what they think about the ergonomics of stuffing the bags into the slots. This is one example of that. So you can see an MO3 bag being dropped in through the top of the Dragon capsule. That is the central stack. So at this point, all of the cargo has been loaded into the walk-in closet shelving units. The central stack is being dropped in. And you can see an engineer here pushing one of the soft CTB bags into one of the slots. And again, that is strapped in with basically seatbelts. Next slide, please. And then to just give you a couple notes on the Dragon Lab program, we're really not going to focus on that in this forum, but if you do have questions afterwards, please come up and talk to me about it. The idea with Dragon Lab is to be an orthogonal supporter to the International Space Station. So the International Space Station is a widely capable platform. What our goal for Dragon Lab is to fill the little niches not quite filled yet. So for example, if you did want to fly your class rings and send them up and bring them down and sell them on eBay, that is what the Dragon Lab will be for. If you found that you had some hardware trapped in the valley of death of the technology readiness levels, you could fly that on the Dragon Lab spacecraft. Sometimes it's cheaper to get heritage than go through all of the testing of fully vetting your technology demonstrations, and that's something that we can do here, especially in preparation for going to the International Space Station. If you want to test out your hardware before you get there, this is a way to do it. So go ahead into the next slide, and the next slide. So for your future reference, when you get these slides back at home, there are some technical specs on Dragon Lab. There is increased power capability, increased communications capability to the CRS spacecraft. Next slide, please. And you can use this just for your reference. And next slide. So this is the manifest that we have coming up for all the way out through 2017. Everything NASA related is highlighted. You see the bulk of the business that we're doing right now is for NASA, so these spacecraft and providing accommodations for these payloads is pretty important to us. The Dragon Lab flights for 2012 and 2013 will be taking advantage of all that we have learned up until that point. Next slide, please. And that's it, so I'm happy to take any questions. Also take a lot of questions offline. I know that all of the implementation partners will be available outside to talk after this. We're getting out a little bit early, so please don't run too fast. Everyone has lots of things to talk to you about. Yes?
I have a question.
Yes.
Your Dragon right there, you're going to have communications and stuff. Will y'all be utilizing the ground sites that the NASA utilize or use TDRS?
We have set up our own network of ground stations. So we will have high-speed ground communication. We will have moderate-speed TDRS communication.
Okay. And that's going to be on the multi-access antennas?
I'm sorry, on what?
Is it going to be on the multi-access antennas?
Yes.
What are the attach points for the unpressurized payloads?
Sure, that's a really good question. There are a couple different ways that we accommodate that. The most basic is a cargo carrier rack, which attaches to the inside of the trunk right against where the heat shield for the Dragon would be.
So you have a cargo carrier there?
There is a cargo carrier. For NASA payloads, what we generally attach to that cargo carrier then is FRAMs. So all of the ROUs will come up on FRAMs. We can accommodate up to 4 at a time. And then the other way that we bring in payloads is actually attaching to the second stage of the rocket. We can put ESPA and CubeSat payloads in that area. So we stack from the cargo carrier in one direction and the ESPA ring in the other direction. Again, as
that's neat.
Only as is allowed by the primary spacecraft. So the primary spacecraft is always our first priority. If they don't want secondaries, they don't have secondaries. But we do have the ability to carry as much of that as possible.
Okay, and the other question I have is about Dragon Lab.
Mm-hmm.
I couldn't quite understand the the flight profile of Dragon Lab. What is it going to do? I mean, it's not going to go to station, right? Dragon Lab?
That's a very good question. Yes,
Yeah.
that is absolutely true. Dragon Lab will not be going to the International Space Station. So when we launch Dragon, Dragon goes up to a preset orbit. That orbit has not yet been determined. A lot of payloads want to go to sun synchronous. We send that up to a preset orbit, and it stays there until we deorbit it and bring it back. And that could be anywhere, as I said, between 2 weeks and 2 years. Does that answer your question?
So if let's say a payload developer sends something on the Dragon Lab, like you said, to do some, advanced testing instead of doing ground testing.
Yes.
Is that going to see just microgravity, or is it also going to see vacuum?
For a pressurized payload, if a pressurized payload wants to see vacuum.
No, pressurized payloads don't need to see vacuum.
Okay.
I'm talking about unpressurized payloads.
Oh, unpressurized, yes. All unpressurized payloads will be in vacuum.
In vacuum, okay.
Yes. Any more questions? Okay, well, thank you very much. Again, all the implementation partners will be outside, so please don't jump away too fast, and we'll be around to answer questions. Thank you.